For the next set of problems, we have a spring scale, which is going to be reading Fg, or the weight of our objects. The way a spring scale works is, here's our scale. We've got a force, in this case gravity, pulling down, and then the scale has an upward force, and this is what the spring scale reads. Now we have this conversion factor, 1 kilogram is 9.8 newtons, and we're going to use it for the rest of the problems. So let's find the force exerted by gravity on a 5 kilogram object. Let's put 5 kilograms, so 5 kilograms. Now let's use our conversion factor. I've got kilograms here and I want newtons, so I'm going to put kilograms in the denominator, newtons in the numerator. Now what is my conversion factor? I've got 1 kilogram is 9.8 newtons. Then I multiply straight across. 5 times 9.8 is 49 newtons. So I'm going to come up here and put 49 newtons. All right, now we're looking for the force exerted on gravity by 98 newtons. So we're going to start now with 98 newtons, and we're looking for kilograms. So I want kilograms in the numerator and then newtons in the denominator. Now for this case, I know, let's see, 1 kilogram is 99.8 newtons. So I multiply straight across. 98 divided by 9.8 is of course equal to 10. So I know 10 kilograms is going to be 98 newtons. Now, for the last one, I've got 70 kilograms. And in these, I do put my units. I've got kilograms in the denominator, newtons in the numerator. I know 1 kilogram is 9.8 newtons. Multiply straight across. 70 times 9.8 is, real quick, 686 newtons. Excuse me, 686 kilograms. So kilograms cancel. I'm left with newtons. Now for fun problems. What acceleration will result when a 12 Newton force is applied to the right on a 3 kilogram object? All right. So let's look at my free body diagram here. I have a mass. I have Fg going down. I have Fn going up. And I'm applying a force to the right. I know my force is 12 newtons. And I know the mass is 3 kilograms. These are your givens. Go on and write them down. And we're looking for the acceleration. So my unknown is acceleration. All right, I know F equals ma. This is my equation. And I'm looking for the acceleration, so I'm going to solve it for acceleration. I'm using gas, as you can see. G-U-E-S, S. So I divide both sides by m. So the acceleration is F divided by m. So my acceleration, now I'm just going to plug my numbers in, is the force, or 12 newtons, divided by the mass, or 4 meters per second squared. This is actually part B. What is going to be the acceleration if I change my force and I apply it to a 6 kilogram object? In this case, F is still 12 newtons, but M is 6 kilograms. I'm still looking for my acceleration. My equation is F equals ma. Solve for A. This is F divided by m. Plug my numbers in. The force is 12. The mass is 6. So the acceleration, 6 divided by 12, is 2 meters per second squared. Number 12, I have a net force of 16 newtons causes a mass to accelerate to the left at a rate of 5. Find the mass. Okay, free body diagram. Fg goes down, Fn goes up, and I have a net force of 16 newtons, and I've got it accelerating to the left. So let's look at this. F net is 16 newtons, and that's its value, and the acceleration is 5 meters per second squared, and this is to the left, so I'm going to put a negative sign in there. All right, we want to find the mass. Right here are my givens. My unknown is the mass. My equation is F equals ma. Solve it. Solve for mass. Mass is F divided by A. So the force is 16 and the acceleration is 5. So the mass is 3.2 kilograms. When I'm looking for mass, I'm not going to worry too much about the signs. I know my net force is technically negative, goes to the left. Acceleration is to the left. 13. I have an object is accelerating at 2 meters per second squared. If the net force is tripled and the mass is doubled, what's the new acceleration? There are a couple ways you can do these. Let's first draw my free body diagram. This is M, and it's accelerating at an acceleration of 2, and obviously I've got some force applied. Now, in my second case, let's go to another color, let's go to brown. What we're going to do is the net force is going to be tripled, so this is a new force, and the mass is doubled, so we have a new mass. So let's write out what we have to start with. We know F equals ma. And I know originally my acceleration is 2 meters per second squared. I don't know what the force is. Let's look at our second case. F prime equals m prime a prime. The prime just means my second case. Now I know the net force is tripled, so I know my new force is going to be 3 times my original force, and the mass of my object is doubled, so m prime becomes twice my original mass. And I'm looking for the new acceleration. So my unknown in this case is my new acceleration. Prime now. Again, there are a couple of ways you can do these. I think the ratio method is the easiest. What I'm going to do is simply write F prime equals m prime a prime, and I'm going to take a ratio of that and my first equation, F equals ma. So let me just erase this part right here. You see, while I'm dividing the two equations, I can really divide F prime by F and m prime a prime by ma. Now I'm going to go to black here and let's trade some of these numbers. I know F prime is 3F, so I'm going to take this right here and plug it in. I know M prime is 2M, so I'm going to plug that in as well. Look what happens to this equation. I'm going to rewrite the equation here. F prime is 3F divided by F equals, and I'm going to leave MA down here. M prime is 2M, and I'm multiplying by A prime. Look what just happened. Now I've got a ratio set up where my forces cancel, my masses cancel, and I'm left with an equation in A and A prime. So I'm going to solve this for A prime by cross multiplying. So A times 3, so this is 3, A is equal to 2, A prime. And I'm looking for A prime. So A prime is, what, 3 divided by 2 times A. Now, A is 2 meters per second squared. So I'm going to plug that in. So this is 3 divided by 2 times 2, or my new acceleration is 3 meters per second squared. Sometimes you can logic your way through these. This method will always work. Let's try it now. An object is accelerating at 2 meters per second squared. So A is 2 meters per second squared. I have some force, and I have some mass. Now, the net force is tripled, so F prime is 3 times my original force. The mass is halved. M is 1/2 the original mass. Now I want to find the new acceleration. Let's do the same process. All right, switch colors here. Let's do F prime equals M prime A prime. And I'm going to divide that by the equation F equals M A. Don't like that color? Let's switch again. Now F prime is 3F. So this becomes 3F divided by F equals M prime is 1/2 M times A prime divided by MA. I like crossing things out. F's go away. M's go away. So now I'm just left with an equation in A prime and A, so I'm going to cross multiply. So I have 3 times A is equal to 1/2 A prime. A prime is what? 3 times 2 times A, or 6A. Now I'm going to plug in A is 2 meters per second squared. So this is 6 times 2, or 12 meters per second squared. Now I have a crate of 50 kilograms. Is accelerated to the right with a magnitude of 3 meters per second squared. Find the net force. My givens, I have the mass is 50 kilograms. I have an acceleration of 3.5 meters per second squared. And I want to find the net force. So my unknown is the net force, or you could just use F, that's fine. My equation, F equals M A. I don't have any solving. I'm simply going to plug my numbers in. F is 50 times 3.5, or 175 newtons. 10. Now, a boy pushes a 0.5 kilogram book across a table, exerting a force of 2 newtons. Find the acceleration. Well, this is my mass, so as a given, my mass is 1/2 kilogram. And I have a net force of 2 newtons. I don't worry too much about sig figs. My equation, F equals ma. And I want the equation, let's see, I want the acceleration. So my unknown is the acceleration. My, that's my equation. I got these out of order. I'm looking for my unknown. I'm going to solve my equation now for acceleration. Acceleration is F divided by M. So this is 2 divided by 0.5, or 4 meters per second squared. Now I have an applied force of 50 newtons, accelerates a 100 Newton object to the right across a frictional surface. It encounters 10 newtons of frictional force. Okay, we have to have a free body for this one. Here's my block. Now I have an applied force of 50 newtons. So F equals 50 newtons. Don't try and write this on your free body diagram. Just label it F and then write what F is over here. It's used to accelerate a 100 Newton object. This is the weight of my object. This is Fg. So Fg is equal to 100 newtons. The object encounters 10 newtons of friction. So I've got friction going back here. So friction is 10 newtons. Find all of the forces. Let's see. I need to draw in my normal force, and I need to draw in the acceleration. So I've got a good free body diagram. Let's go figure out what we can figure out. To start with, let's see. I have, whenever I give you the weight, find the mass. Whenever I give you the mass, find the weight. So the first thing I'm going to do is find the mass. If Fg equals mg, then the mass is Fg divided by g, or I have a weight of 100 divided by 9.8. So I have a mass of 10.2 kilograms. Now, you usually have to have the mass, so we need to hang on to that. I'm going to sum the forces in y. And this is 0 because the forces aren't moving. The object isn't moving in y. I have Fn going up. So this, remember, is my arrows. So this is Fn. I have Fg going down. So it's minus Fg equals 0. So the normal force has to equal the force due to gravity. And so I have this as 100 newtons. Next, I'm going to sum the forces in x. And this equals ma. Alright, what forces do I have in x? I have F going to the right, so that's going to be positive. Minus friction going to the left, so that's negative. And this equals mass times acceleration. Now this is kind of interesting. Whenever I give you the force, like I've given you, F and friction, I can find the net force. So F net, in this case, is going to be F minus friction. So this is going to be 50 minus 10, or 40 newtons. To find the acceleration, I come back up and I can say F net equals ma. Since I've already found this value, I don't have to refind it. So the acceleration is F net divided by m. So it's 40 divided by 10.2, or 3.92 meters per second squared. You could have found it from up here and plugged in from up here. That would have been just fine. Now, what's the frictional force when a 750 kilogram car travels on a road and I have coefficient of friction of 0.4? Now, it seems like I haven't given you enough information. Let me write down my givens. Switch my pen color real quick. I've given you the mass, and I've given you the coefficient of friction, mu. Let me draw a free body diagram. I've got Fg going down, I have Fn going up, and then I'm going to have some sort of friction. Whenever you're looking for friction, you've got to find the normal force to start with. So we need to sum the forces in y, and this is 0 because it's not moving in y. So Fn minus Fg equals 0. Fn is going up, Fg is going down. So the normal force has to equal Fg. Really good. I know my formula for weight is mg. Now I'm just going to hang on to this for a minute. I've got the normal force is mg. My next formula, I know that my frictional force is mu Fn. So this has got to equal mu, and I just found Fn equals mg in this case. So the frictional force here is mu mg. So let me plug my numbers in. 0.4, the mass is 750, and g is of course 9.8. So we get the frictional force is 2,940 newtons. Now you see the frictional force doesn't depend upon the acceleration. I don't know what other forces are being applied. Now I have a 52 Newton sled being pulled across a cement sidewalk. Oh, we know we're going to have friction there. Let me draw my free body diagram. Let's start with Fg. I'm going to go up with my normal. A horizontal force of 36 newtons is applied. What's the coefficient of sliding friction? So we have friction going back here. Let's see. I have a 52 Newton sled. That is my weight. That is Fg. I know the velocity is a constant, which tells me the acceleration is 0. That's good. And I have an applied horizontal force, F of 36 newtons. And I'm looking for mu. All right. The first thing I want to do is sum the forces in y, because I need mu, so I need my normal force. So I'm going to sum the forces in y, and this is 0. The forces I have in y, I have Fn going up, so it's Fn, minus Fg going down. So Fn equals Fg. So I have the normal force is equal to 52 newtons. Next, I'm going to come over and sum the forces in x. And it equals 0 because my acceleration is 0. So I have my applied force going to the right, and then subtracting friction, which is going to the left. My applied force, let's see, let me solve this for friction. So friction is my applied force. So friction has to equal this F, which is 36 newtons. I'm not done because I'm looking for mu. And I know from my equations that friction is mu Fn. I'm going to solve this for mu. Mu then is my frictional force divided by the normal force. Let's see. I calculated my frictional force is 36. I calculated the normal force is 52. So I get a coefficient of friction of 0.69. No units. Now suppose it's being pulled on snow, and the coefficient of friction drops to 0.12, and we've added a person of 650 newtons. What force is going to be needed to slide it across at a constant speed? We have this same free body diagram. We have Fg going down, we have Fn going up. We're going to have to apply a force, and we need to figure out what that force is, and then we have friction. But a few things have changed. I still have this 52 Newton sled, but I've also got a 650 person sitting in there. So Fg in this case is going to be Fg of the sled plus Fg of the person. So this is going to be 52 plus 650, or what? 702 newtons. And now mu is 0.12. We need to sum the forces in y to find the normal force. Sum of the forces in y is 0 because it's not moving in y. I have Fn going up minus Fg going down equals 0. So in this case, Fn again equals Fg. This is getting to be pretty convenient. So my normal force is 702 newtons. Next, I'm going to sum the forces in x. And, we're moving at constant velocity, so our acceleration is 0 in x. That's very good. So the forces I have acting are F minus friction equals 0. So force applied has to equal friction. Friction is mu Fn. Now let's see, mu is 0.12, and Fn is 702. Calculate it from over here. Got those two. And so I got a value of 84.24 newtons. Now needs to be applied to keep this moving at a constant speed. Please note, this is 84 newtons after I've added a 650 newton person, where over here it took an applied force of 36 newtons to simply get the sled itself started. So you see how the kinetic friction is substantially less than the static friction. These are fun problems. I have an applied force of 20 newtons. So, to accelerate a 20 kilogram object to the right across a frictional surface, and it gets 10 newtons of friction. Find everything. All right, draw your free body. I have Fg going down, Fn going up. I've got an applied force F, friction going back, and in this case we do have an acceleration. Let's write out our givens. Come over here. F is equal to 20 newtons. Mass is 20 kilograms. Friction is 10 newtons. We want to find everything. First thing let's find is the weight, because Fg equals mg. I gave you the mass, so you can find the weight. So this is 20 times 9.8, or 196 newtons. You know it's coming. I'm going to sum the forces in y, and that's 0. I only have two forces in y, Fn and Fg. Fn points up, so it's positive. Fn minus Fg equals 0. So the normal force equals gravity, or 196 newtons. That was easy. Now, I have found my frictional force. Let's go on and find mu, because I can do that with just an equation. I know friction is mu Fn. So mu is going to be my frictional force divided by the normal force. In this case, my frictional force is 10 newtons. My normal force is 196. So I get a mu of 0.051. Now, let me find the net force. This is kind of a straightforward. F net, you remember, is just the summation of the forces. So what forces do I have acting? I have F to the right minus friction to the left. So F is 20. Friction, I'm using this one, and then I'm using this one. Friction is 10, so it's minus 10. So in this case, my net force is 10 Newton. Rewrite that. Finally, I use F net equals MA. I'm going to solve this for the acceleration. The acceleration is F net divided by m. So F net is 10. My mass is 20. So the acceleration is 0.5 meters per second squared. All right, 22. I have a 5 kilogram object sliding to the right, and it gets friction, which is slowing it down. I have the coefficient of friction. Find the force of gravity, normal, frictional, etc. Okay, here's my free body diagram. I have Fg going down, and I have Fn going up. Now it says it's sliding to the right, so it's moving this way. Since it's moving to the right, that means friction is to the left. Let me come over here and write out my givens. All I know is mass is 5 kilograms. All right, I know that. And the only other number I have is mu, is 0.1. Now let's look at this. Come back over here. I don't have any other applied forces, so we're not going to make one up. First thing you do, of course, is find Fg if you have it. Tell you what, let's sum the forces in y first. Sum of the forces in y is 0. The only forces I have acting in y are the normal and Fg. You're starting to see a pattern here, aren't you? Fn minus Fg equals 0. So the normal force is equal to the force due to gravity, which is mg. So let's plug this in. This is 5 times 9.8, or 49 newtons. So I've gotten the normal force and gravity in one shot. Once I have the normal force, I can find the frictional force. Friction is mu Fn. So this is 0.1 times my normal force, which is 49. Or friction is 4.9 newtons. All right, let's see. I found that one, and that one, and that one. All right, let's do my net force equation now. F net, or let's look at some of the forces. In this, let's just look at the arrows. The only arrow I have is friction, and it's going to the left. So F net is minus friction. So this is equal to minus 4.9 newtons. All that negative sign means is I'm going to the left. Once I have the acceleration, once I have the net force, I can find the acceleration. So F net equals ma. Solve for acceleration. It's F net divided by m. So this is F net is minus 4.9 divided by 5, or negative 0.98 meters per second squared. And all that negative sign means is my acceleration is this direction. All right, 23. I have a rightward force that's applied to a 6 kilogram object. Okay, so I've got the mass. It moves across a rough surface. Rough means there's going to be friction. Constant velocity. The object encounters 15 newtons of frictional force. Find everything. Let's first do this one by start with our givens. M is 6 kilograms. Friction is 15 newtons. Start by drawing a free body diagram over here. Fg goes down. Fn goes up. And it says it's a rightward force. So I've got a force applied. And I get friction going back. Now, because we're moving at a constant velocity, I know A is 0. Let's sum the forces in y. Summation of the forces in y equals 0 because it's not moving. I have Fn pointing up, so Fn goes up. Minus Fg points down equals 0. So in this example, again, Fn equals Fg equals mg. So this is going to be, the mass is 6 times 9.8. So this is 58.8 newtons. All right. So now I have found Fg and Fn right there. I can automatically write down net force is 0. All right. F net and x is 0. F net and y are 0. Why? Because my acceleration is 0. So now I found F net. So let's go and sum the forces in the x direction. This is going to equal 0 because the acceleration is 0. So I have an applied force F minus friction equals 0. So my applied force has to equal my frictional force, and I've found that my frictional force is 15 newtons. So this is 15 newtons, and it's to the right. So now I found Fa. The last thing I need to find is mu, and I know my formula, friction, is mu Fn. So mu is my frictional force. Changing my notation there, sorry about that. Let's use the same notation. Friction divided by Fn. Frictional force is 15 newtons, and Fn is 58.8. So mu, in this case, is 0.255. There are no units. Rightward force is applied to a 10 kilogram object, so this is going to be my mass. To move it across a rough surface, so I know there's friction. Constant velocity tells me A equals 0. The coefficient of friction is 0.2, so I have mu. Let's start by drawing a free body diagram. Fg goes down. Fn goes straight up. I've got a rightward force, so the force itself is applied right, and therefore friction goes left. It's very important you check that direction there. And it's moving at a constant velocity, so A is 0. Write down your givens. I know the mass is 10 kilograms. And A is 0 in every case. I'm going to go and write that down. Mu is 0.2. Right off the bat, I can tell you that the net force is going to be 0 because the acceleration is 0 in x and y. So you can just write that down. F net in the x direction is 0. F net in the y direction is 0. Alright, let's sum the forces in y. And we know that equals 0. Summation of the forces in y is 0. I have Fn going up, so it's Fn, minus Fg going down, equals 0. So the normal force equals Fg, and we know Fg is equal to mg. So the mass is 10 times 9.8. Both of these are 98 newtons. So we have taken care of these two as well. Once you have the normal force, let's go on and find friction. Friction is mu Fn. So it's mu, which is 0.2, getting from there, times the normal force, which is 98. So I get friction is equal to 19.6 newtons. So now I figured friction out. Let's sum the forces in x, and this equals 0. So I have F minus friction equals 0. So my applied force has to equal my frictional force, and that is 19.6 newtons. So now I found the last thing I'm looking for. Alright, now I have a rightward force of 25 newtons, alright, being applied to a 4 kilogram object. So I have a force of 25 newtons applied to a 4 kilogram object, so my mass is 4 kilograms. And I have the acceleration is 2.5 meters per second squared. Draw an FBD and find everything. So let me finish my FBD. I've got gravity going down, normal going up, and friction. And I have an acceleration. I didn't even know that acceleration. Well, let's sum the forces in y. Sum of the forces in y is 0 because it's not moving in y. I have Fn going up and Fg going down. So it's going to be Fn minus Fg equals 0. So the normal force is equal to the force due to gravity. So this is equal to mg. So the mass is 4 kilograms. Gravity is 9.8 meters per second squared. So Fg and Fn are equal to 39.2 newtons. So those two are taken care of. One fell swoop. I can find Fnet in y. Fnet, in x equals ma, because I have both the mass and the acceleration. So Fnet is going to equal the mass, which is 4, times the acceleration, which is 2.5, or 10 newtons. So I found that one. They want the frictional force. In order to find the frictional force, I'm going to have to do just a little bit more. Let's go and do the sum of the forces in x equals Fnet in x, which is ma. I'm just writing this. You don't have to write this part. Sum of the forces. These are my arrows. So I have F going to the right minus friction going to the left equals ma. And in this case, I know ma is also equal to 10. Let me plug in what I have. I have 25 newtons minus friction is equal to ma, right here, is 10 newtons. So let me get friction by itself. I'm going to add friction to both sides. So 25 is equal to 10 plus friction. Subtract 10 from both sides. So friction is 25 minus 10, or 15 newtons. Once I have friction, I can find mu, because I know friction is equal to mu Fn. So mu is friction divided by the normal force. Friction is 15 newtons divided by the normal, 39.2, or it's 0.383. Make sure your decimal's there. There we go. Found everything. 26. A box that weighs 60 newtons needs 50 newtons in order to overcome friction and move it at a constant velocity. Okay, let's find the coefficient of static friction. Let's draw a free body diagram. Fg goes down, Fn goes up. Now we're going to apply a force, and that's got to overcome static friction. Because we're overcoming static friction, we know the acceleration is 0 because it's not moving in x or y. Now I told you the box weighs 60 newtons. So Fg is 60 newtons. And my applied force F is 50 newtons. All right, sum the forces in y is 0 because it's not moving in y. I have Fn going up, I have Fg going down, and it's equal to 0. So the normal force is equal to the force due to gravity. And I already found out from the problem that the force due to gravity is 60 newtons. Once I have the normal force, I can come and find the coefficient of friction, because I know friction is mu Fn. Oh, I need to find out what my friction is first. Whoops. Let's back up. Happens to the best of us. First thing I need to do is sum the forces in x. Sum of the forces in x equals 0 because the acceleration in x is 0. So I have an applied force to the right minus static friction is 0. So my static friction has to equal this applied force. So friction has to equal 50 newtons. So now I can come over and calculate coefficient of static friction, because friction is equal to mu Fn. Solve for mu. Mu is frictional force divided by the normal force. So friction is 50 newtons divided by the normal force, which is 60. 0.83333. Now, I have a metal crate that has a mass of 50 kilograms and a coefficient of static friction of 0.4. How much force must be needed to get it moving? Oh, let's draw a free body diagram. Free body diagram, I have Fg going straight down. I have normal force going straight up. And I'm going to apply a force and friction. Write down my givens. M is 50 kilograms. And mu, static, is 0.4. What force has to be applied to get it going? In order to get it going, we know it's not moving, so the acceleration is 0. Okay, sum the forces in y is 0 because it's not moving in y. So I have Fn minus Fg equals 0. So the normal force has to equal the force due to gravity. So this is going to be mg. Let's just leave it like this, really, for this one. Let's sum the forces in x now. This is equal to 0 because the acceleration is 0. So I have an applied force has got to minus frictional force equals 0. So I know the applied force has to equal the frictional force. Now, I'm just showing you a couple shortcuts here. Friction, the equation for friction is mu Fn. Now I didn't solve for the value of Fn back here. So I'm just going to plug in mu mg. So now to find the applied force, this is mu, which is 0.4, times the mass, which is 50, times 9.8. or it's 196 newtons. It's perfectly okay to do the problem like this. All right, for part B, now mu is 0.32, and I'm moving at a constant velocity. So all of these equations are the same. The normal force is going to equal mg. The applied force has got to equal friction. So the applied force has to equal friction, which is mu k Fn, because now this is mu k because it's moving. So it's kinetic. So it's mu k, and the normal force is equal to mg. So my new mu k is 0.32. Mass is 50. G is 9.8. So now this is 156.8 newtons. So now the applied force needs to be only 156.8 newtons.